Good morning, students. Unit 3 Mechanical Properties. Today we will discuss the second mechanical property, hardness. Hardness is the ability of the material to resist plastic deformation or permanent deformation of material. Deformation means a change in shape or size of the material. To illustrate, consider an rubber band. When a load is applied to the rubber band initially stretches. When the load is removed, the rubber band retains back to its original position. This is called elastic deformation. Suppose when more amount of load is applied to the rubber band, the material stretches, elongates. At certain point, it loses its stretching ability and cannot retain back to the original shape. At this point, the material changes its size and shape plastically. That is, it cannot retain back to the original size and shape. So that is called permanent deformation or plastic deformation. How to measure the hardness of the material? The answer is indentation test. What is indentation? Look at this picture showing the principle behind the indentation test. You have a rectangular specimen whose hardness of the material has to be determined. You have a heavy steel ball of known diameter. Suppose a load of 10 kg is applied to the steel ball and it's made to press on the specimen surface. An impression is formed on the surface of the material. If a load is small, the impression made on the surface is small, and if the load is heavy, the impression made is of higher with a large diameter. Knowing the diameter of the impression and the applied load, the hardness of the material is determined. This test is called indentation test. So, it measures the resistance of a sample to material deformation due to constant compression load from the sharp objects. So, the objects which is used to make impression on the surface of the testing sample are called the indenter. Various methods are used to measure the hardness of the material in engineering and metallurgical field. They are Brinell's hardness, ROCKWELL'S hardness, Vickers micro hardness and Noob micro hardness. For today's presentations, we will concentrate both on Brinell's and ROCKWELL'S hardness. This is the Brinell hardness testing machine. A load is applied from the top and the value of the load is read from the dial machine. You have a plunger, long elongated steel, below which the indenter steel ball is placed. The specimen is placed at the top of the anvil. A hand wheel is placed to screw and tighten the specimen. This picture shows the procedure involved in Brinell's harness testing. A known load is applied from the top of the specimen. A Brinell steel ball indenter of known diameter 10 mm is placed at the top of the working specimen or workpiece. When the load is applied, an impression or indentation is formed on the surface of the workpiece. Its diameter, small d, is measured from the travelling microscope. A load of nearly 500 to 3000 kg is applied for 10 to 15 seconds. Knowing the load capital P and diameter of the indenter steel ball capital D and measuring the diameter of the indentation formed on the surface with the help of microscope, a formula is applied to measure the hardness of the sample and it's called Brinell hardness number. The Brinell hardness number is given by load divided by surface area, which is equal to 2 capital P divided by pi capital D into D minus D square minus D square under the root, where capital P is the applied load, capital D is the diameter of the indenter ball, small d is the diameter of the indentation made on the surface of the specimen. The accepted advantages and disadvantages of Brinell's hardness testing is tabulated. The method is widely accepted and used. When a large steel ball indenter is used, the readings are very accurate in a single test. The results are more accurate and accessible. The principle and method to operate the testing machines are very easy. On disadvantages, the measurement is destructive. When a heavy load is applied, there is a possible for the steel indenter ball to damage. It is non-portable that cannot be carried from place to place. The testing machine initial cost is quite high. There is a possibility for the error to occur during the operator's reading the Brinell's microscope. A maximum error of 10% is attained. The second method to measure the hardness of the material is ROCKWELL'S hardness testing method. Here, the hardness of the material is inversely proportional to the depth of indentations or penetrations or impression. In this method, loads are applied in two forms. Initially, a minor load is applied followed by a heavy load so that impression is made more in depth and the readings are more accurate in reading. As the hardness and penetrations are inversely proportional, hard material will produce a less penetration, whereas soft material will produce more penetration. This shows the ROCKWELL'S hardness testing machine. You have a dial machine which reads the applied load, a plunger to have the indenter and the specimen whose hardness has to be measured. You have a hand wheel to screw and tighten the specimen. A microscope screw is given attached with the instrument itself to move along x directions and y direction to measure the depth of penetrations more accurately. In Rockwell hardness testing machine, two types of indenter are used, either a steel ball or diamond cone braille. The surface of the indenter is diamond anvil of an angle 120 degree. Either a small steel ball of 1 by 16 inch diameter or heavy steel ball 1 by 8 inch diameter are used as an indenter in Rockwell hardness testing. The principle involved in Vickers hardness testing is clearly explained below. Consider a rectangular specimen whose hardness has to be measured. The base of the material acts as a zero reference line. Initially, a minor load F0 is applied on the indenter. Due to small load, a small depth of penetration is produced. This is first measured with the help of microscope. To have the depth of reading more accurately, a heavy load, major load F1 is applied along with the minor load F0. So total load capital F act on the indenter. Now the depth of penetration increases. The difference in depth of penetration with respect to the total load and the minor load is measured with the help of microscope. This measurements indirectly calculate the hardness of the material. To recall again the Rockwell hardness testing, the first two types of indenters is used, either a hard steel ball, the diameter ranging from 1 by 16, 1 by 8, 1 by 4, 1 by 2 inches, or diamond cold braille indenter whose angle is 120 degree and the tip radius is 0.2 mm. Here the load is applied in two forms, initially a minor load of 10 kg followed by a major load ranging from 60 to 150 kg. The Rockwell's measurements is read by two scales, B scale and C scale. In B scale, Steel ball indenter of 1 by 16 inch diameter is used. The applied load is 100 kg and is used to measure hardness of non-ferrous materials. Whereas in C scale, diamond cone braille indenter is used. The angle is 120 degree, applied load is 150 kg and is used to measure hardness of steel. The advantages and disadvantages of Rockwell hardness testing is tabulated. Under advantages, the Rockwell number is directly read from the dial machine. The testing is done very rapidly. The material of any range can be tested with the help of Rockwell hardness testing machine. Under disadvantages, possible error due to manual shifting of the sample during test may take place. It is non-portable that cannot be carried from place to place. The quality of the indenter, such as the diameter of the steel ball or the angle 120 degree in a diamond cone braille indenter, plays a very important role in the testing results. Thank you.